So we're going to talk more specifically about what a polynomial looks like when it's factored and how we can find the roots of a polynomial, because when it's factored it's easier to see the roots. Here's a polynomial, y equals x squared minus 4x plus 3, and we see that it has two real roots. Now we can factor this. You know how to do this. You know how to factor quadratic polynomials. If you multiply -1 times -3, you get +3, and if you add -1 to -3, you get -4. So this is the correct factoring. So of course if we graph this, it's going to be the same graph. Okay, so we see that the graph is the same. Now if we were to set this polynomial equal to 0, and I asked you, well, what are the roots of this polynomial, might not be all that obvious. And if you look at this polynomial, and I said, well, if this polynomial equals 0, what are the roots? It would be more obvious. You think of the numbers of x that would, when you substituted them in, would produce a 0. So 1 minus 1 is 0, so +1 is the first root. And 3 minus 3 is 0, so +3 is the other root. And we can see, if we look at the graph, well, indeed, x equals 1 is a root, and x equals 3 is a root. 1 and 3 are the roots, and that corresponds to the factoring of this. Now if we change the sign of one of these, zoom out here, now our roots are +1, and we have to think of what number when you add it to +3 would give you 0. Well, -3 plus +3 is 0, so we see a root here. So this is the preferred form of writing a polynomial. Now you can't always factor a polynomial. If it doesn't have real roots, it's tricky to factor, and then you have to start thinking about complex numbers.